Hi, this is your TA Karthike, and today we're going to talk about planning versus searching and assignment 2 in general, in particular, hill climber. So let's just jump into it. The first main difference between planning and searching is that planning uses a structured or factored representation of states, while searching uses an atomic representation of states. Further, in planning, actions have requirements and consequences that should constrain the applicability in a given state. That is, in planning, there is a stronger interactions between actions and the states needed. Further, in a lot of problems, most parts of the state world are independent of other parts. So you need to solve sub goals independently, that sub part or an independent component of the state world. And essentially, even in your book, a planning problem could be reduced to a searching problem, but the search space would be humongous, and that's why we don't do it. Even suppose, for example, your map coloring problem or solving a sudoku, it could essentially be reduced down to a search problem, but we don't do it that way because it's inefficient. You formulate it as a constraint satisfaction problem, and that's much more efficient. Well, anyways, we continue to the assignment now. So the first part is hill climber. So what hill climber is generally used on optimization problems, and hill climber is a local search algorithm. And what it does is it tries to it keeps track of only a single state or node, and it tries to find the best node according to some objective function. The problem with hill climber is it gets stuck on a local minimum or local maximum, and thus we use simulated annealing or random restart hill climbing so that it actually finds the global maximum or minimum. Now, coming on to the assignment, or rather hill climbing in the context of Pac-Man. Well, this is what you need to do. um, you have an initial state, and here are your list of possible actions. Now first you need to do is you need to create an action sequence of length 5, which just consists of random actions from these list of possible actions. You can do that using the pseudo code here. Now that was just the initialization part. Now we come to the actual hill climber algorithm. So what does the assignment say? The assignment says that each action in the sequence has 50% chance to be changed into a random action. So suppose after doing all this, this is what you get as an action sequence. And I'm talking about before starting your main algorithm, obviously. Okay, so that's all the initialization part, and now your algorithm actually starts. So for the first thing that you need to do is this thing, this here. Each action in the sequence has 50% chance of being flipped. So you iterate through your action sequence, this sequence, and each time you flip a coin using, you could say, rand.randint 0,1, and if it's a 0, you flip this action, and if it's a 1, you leave it be. On to the next one. If it's a 1, you leave it. If it's a 0, you change it. Similarly till you have iterated through this whole action sequence. So suppose after randomly changing it like this, we have a new action sequence which looks like this. Okay, now what you need to do is evaluate it. And what I mean by evaluation is, you have some initial state which we have given you, that is the state. What you need to do is, you again iterate through this randomly generated action sequence from here, like through this. Basically you iterate through this and you generate another state through like this, state dot generate Pac-Man successor for the first action, that is this one, and you get some state S1, right? And I'll just call this method GPS now, generate Pac-Man successor. And now again similarly you go ahead and you do S1 dot GPS this, and you get S2, and similarly you get S3, S4 and S5. Now once you reach S5, that is you have reached that the end of the action sequence, you need to evaluate that action sequence, and you evaluate the action sequence using the game evaluation function, and that's how you evaluate it. So evaluation is equal to game evaluation state comma S5, and this will give you some number. Let's just assume that this returns you X. So we assign a score of X to this action sequence. Now what you need to do is, you just continue. You have this action sequence and it has a score of X. You again change each action sequence by 50% probability, and you get some new action sequence, and then again you evaluate it just like how I told you, and you get some new score. Let's call it Y. And if Y is greater than X, then you know this action sequence is better than your current best action sequence. So what you now do is, you reinitialize your best action sequence to Y, and you keep doing this until you reach the generate Pac-Man successor limit. And you will reach the limit because each time you are evaluating some action sequences, you are generating successors. So you will reach some none in between, or where you start getting nuns. So once you reach the limit of generating successors, all you need to do is return the first action of the current best action sequence so far. So assuming in this example, this action sequence was the best action sequence so far, we did this again and again and again, and I guess this was only the best action sequence. So then what we do is, we just return this. Hope that makes it all clear. Thank you.